Hi guys, in this video you want to make sure that you're following along, you're taking notes down, you're copying all the examples and all the notes that are shown on the slides, and you're working on the you-try problems. This video is going to cover two concepts. The first one's going to be partitioning a line segment. Our objective here is to find the point on a directed line segment between two given points that partitions the segment in a given ratio. So on our graph here, we have segment AB, which is part of line AB, and it tells us over here that point C partitions segment AB in a 1:2 ratio. The word partition means to separate or to divide. So point C has divided our segment AB in this ratio 1:2, which means that this length from A to C, if we were to multiply it by 2, then we would have the length from C to B, since we're in a 1:2 ratio. You can think of segment AB as being divided into 3 congruent parts, so that the length of AC is the length of one part, and the length CB is the length of 2 parts. Alright, so let's take a look at an example problem. Alright, so our first example says that segment LM is a directed line segment from L, which is at coordinates -4, 1, to M at coordinates 5, -5. So let's go ahead and take a moment and plot those. Alright, so now after plotting L and M, I drew a line segment to make the segment LM. Our question says, what are the coordinates of the point that partitions, that divides or separates, the segment in the ratio 2:1? Alright, so the first thing we're going to want to do is we want to find the slope. So I'm going to start at L and I'm going to go to M and I'm going to count. So starting at L, 1, 2, 3, 4, 5, 6. So I went down, so -6. And I'm going to go to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I went to the right 9. Because I know that I need to partition my segment in the ratio 2:1, I know that I need to separate or divide my segment into 3 parts, because 2 plus 1 is 3. So I'm going to take the number -6 and I'm going to divide that by 3. So -6 divided by 3, I'm going to get -2. And I'm going to take the 9, I'm going to divide that by 3, since I want 3 parts, and I get 3. So now I know that if I go down 2 and write 3, that gives me 1 part. Down 2 and write 3, that gives me another part. So now I have 1, 2, 3 parts. If I want to partition my segment LM in the ratio 2:1, then I know that the coordinate that I want to choose is the coordinate that from L to that coordinate, the length there would be twice the length from that coordinate to M. So if I choose this coordinate, then this length in regards to this length is only half. If I choose this coordinate, then from 2 to L, this length would be twice the length from 2 to M. So this is the coordinate I want to choose, so I'm in a ratio of 2:1. So I'm going to go ahead and I'm going to name that something other than 2, not the best name. I'll go ahead and cross that out. I'll call it N, and we need to actually find what those ordered pairs are. So N is the coordinate that partitions my segment in the ratio 2:1, and N is at 1, 2, and then down 3, so 2, -3. And that's my answer. Alright, so you try. Go ahead and pause the video, and then when you're finished with the 2 you try problems, go ahead and continue on. The second concept in this video is about perimeter. So we have 2 learning objectives here. Our first one is I can find perimeter of squares, triangles, rectangles, and circles. And the second one is I can find the perimeter in the coordinate plane. Alright, so most likely you all know what perimeter means. Here's our definition. The perimeter P of a polygon is the sum of the lengths of its sides. So let's look at our first example. It says the Botany Club members are designing a rectangular garden for the courtyard of your school. They plan to place edging on the outside of the path. How much edging material will they need? So in this problem, we definitely need to find the perimeter. And it's not the perimeter of the courtyard itself, but it's the perimeter of the courtyard plus the path that goes around it. So if we check out our courtyard, we see that our courtyard has a width of 16 feet and a length of 22 feet. Since we're going to place the edging on the outside of our path, well, if we look at the length of 22 feet, we have to keep in mind that our path, we're going to add 4 feet to it, and we're going to add 4 feet down here too because the path wraps all the way around it. So I'm going to add that to my picture. So I have the 22 feet, and then I have 4 feet going from here to here, and I have 4 feet again right down here for this path. So really my length is 22 plus 4 plus 4. So my length is actually 30. So this whole length right here is 30. And I have that twice because on this side it's also 30. So I'm going to multiply that by 2. Now looking at my width, again the width was 16. I'm going to use the width up here, 16. And I have to include my path on the right, which is 4, and my path on the left, which is also 4 feet. So 16 plus 4 gives me 24. And again, I have that twice because I have that width on top, 24, and I have the width on bottom, 24. So I'm going to multiply that by 2. Now we want to keep in mind that the perimeter is the sum of the length of its sides. So I'm going to add these together, and that way I can find how much edging material I'll need. So 2 times 30 is 60, plus 2 times 24 is 48, and when I add those together I get 108, and our unit is feet. So I need 108 feet of edging material. Alright, so go ahead, try out the U-try problem, pause it, and then continue on the next slide. This next example deals with our second objective in this concept, which is finding perimeter in the coordinate plane. So our question is, what is the perimeter of triangle? This symbol is a triangle, so that's how we're going to read it. What is the perimeter of triangle EFG? When we talk about triangles, we name them by their vertices. So the vertices, the points, EFG. So to find the perimeter, again, we're just going to add up all the sides. This side from E to F is easy to find because it's a vertical line. So we can simply just count. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. Plus, and again, we have another side that's easy to count from G to F because it's horizontal, so we can just count that. 1, 2, 3, 4, 5, 6. So plus 6. The last side, though, is a little bit more difficult to count because it's not vertical or horizontal. So to find the length of this side, we'll have to use our distance formula. So I'm going to write out what the distance formula is just to remind us. Distance is equal to the square root of x sub 2 minus x sub 1, that quantity squared, plus y sub 2 minus y sub 1, that quantity squared. I'm going to go ahead and I'm looking from G to E. I'm going to call my E my x sub 1 and my y sub 1, and my G my x sub 2 and y sub 2. So I'm just going to plug those in. D is equal to the square root of x sub 2 is negative 3 minus x sub 1 is 3, that quantity squared, plus the quantity of y squared, which is negative 2, minus y sub 1, 6, that quantity squared. So D is equal to the square root of Negative 3 minus 3 is negative 6, and negative 6 squared is 36. Plus negative 2 minus 2 is negative 8, and negative 8 squared is 64. I'm going to go to the side here. D is equal to the square root of 36 plus 64 is 100. And the square root of 100 is 10. So D is equal to 10. So now I know that this length here is 10. So if I want to find the perimeter, I need to add up all my sides. So I have 8 plus 6 plus 10. So our perimeter then, 8 plus 6 is 14, and plus 10 is 24. So I'm going to write that in red. Let's see, 24, and we're just going to say units is our answer. Alright, so go ahead and try the U-Try problem below, pause the video, and then continue on to the next slide. Alright, these are just 3 additional practice problems for you to try, so go ahead and include these in your notes and make them part of your homework, and I will check these tomorrow and we'll go over them in class. Alright, see you tomorrow.